All right, so let's, okay, Blake, I need you to stop talking for me, okay? Thank you. Right. So let's take a look at number 1. Yeah. Okay, so number 1 says find the slope or describe the slope and find it. Okay, do both. Okay, so the first thing is we're going to find the slope. Okay, what's the formula to find slope? Lucas?
Rise over run?
Yep, so rise over run. Now, what if, because this we have a picture, so we're going to be able to count. What if you don't have the rise and the run, and all you're given is those 4 numbers? What's the formula that you could do that looks kind of like that? And you could do it either way in this problem. Yeah, go ahead.
You do y2 minus y1 and x1 minus, x2 minus x1.
Yes. Okay. You can find the slope either way. When I have a diagram, if I can use rise over run, that's easier because all I have to do is count. Okay? So that's what I'll do here. I'm going to count down. 1, 2, 3. Now, if you count down, what kind of number is that?
Negative.
Negative. So you went down 3, and then we're going to go 1, 2, 3, 4. I know the one on the test, your grid didn't print. I'm going to try to make sure on the midterm that the grid prints so it's easier to see. So that's your slope. Down 3, right 4. Now, some people did it with the y2, y1, x2, x1. Okay? If I was going to do it that way, what would y2 be? What would I plug in for y2? Lucas? Yep, we could do that. I'll put a check above it. Minus. What would I plug in for y1?
2.
2. Put a check above it. Okay, I'm just checking them off as I use them. What about x2?
2.
That would be this one. 2. Minus, and what would be x1?
Negative 2.
Negative 2. Perfect. Now, before I go any further, what's going to happen in the bottom when you have 2 minus minus 2?
You turn it into a plus sign.
We'll make that a plus. Okay. So the bottom, we can do that quick. 2 plus 2 gives me 4, which is exactly the same thing I got when I just counted the blocks. What's negative 1 take away 2? Negative 3. So you get exactly the same answer. The only reason I would do it this way on the right is if I didn't have a picture. Okay? You might have one on the test with a picture, you might not. All right, so now we found the slope. Describe it. Okay? What kind of slope is that?
A positive.
It's what kind of slope?
Negative.
Negative, right? Negative 3 over 4. So negative. So when you're asked to describe a slope, there's 4 different slopes you might have to describe. There's positive, which remember, positive looks like that. There's negative, which looks like that. There's a slope of 0, which is perfectly flat. And what do you call the one that's vertical?
Undefined.
Undefined, yes. So those are the 4 different kinds of slopes you can have. Positive, negative, 0, undefined. Blake, do you have a question? Do you have a question? Anything pertaining to what I'm doing? No? You know what? Can I just have you sit over there for me?
Sure.
Yeah, thank you. All right. So especially if this is a short answer question, make sure you tell me the slope and say it's negative, right? If you forgot to tell me it was negative, I'd give you half credit if you only gave me the slope, okay? Because it said to do 2 things. Find it, describe it. So you got to do both. Yep.
We were asked a coordinate.
No, slope you just write as a single number. Yep, just a single number. All right, let's look at number 2. Okay, so this is one a couple people, a lot of people actually asked me about. The amount of miles you ride after spending X hours on your bike. So the directions are to find the domain and then just say if it's discrete or continuous. Now, what letter is domain?
X.
Yes. They didn't ask for range here, but you should know that domain is the X, range is the Y. So in this case, what's X? Like in the real word problem.
Oh, hours.
It's hours. So that's hours. And the range, that's your Y. What's the other thing in this problem besides hours?
Miles.
Miles. Okay. So we're focusing on the domain, which is X. So find the domain. To figure that out, all you have to do is ask yourself, what kind of numbers can you use for X? The three things I ask myself in my head, can I do like positives, negatives, zeros? And then I think about, all right, once I know that, can I use decimals? Right? So let's look at X. Could hours be negative? No. You can't bike a negative number of hours. So negatives don't make sense for the domain. Could you bike 0 hours? Yeah. Could you bike a positive number of hours?
Yes.
Okay, so now we know that it has to be 0 or positive. Now, could you have fractions of an hour? Could you bike like 1.5 hours? Yeah, exactly. Right? Now, when you're buying something at a store, sometimes the decimal doesn't make sense. Like if you go in and you're going to buy like I said, candy bars. You could buy 1 candy bar, you could buy 2. You can't buy 1.5 candy bars. They don't sell it. You buy the whole candy bar or you don't buy it. But with time, you can definitely have parts of an hour. So the domain here would be anything greater than or equal to 0. You could also write that out. X is any number greater than or equal to 0. Can't be negative. That doesn't make sense. But it could be a decimal. If it said, if it was the candy bar problem, okay, the way you described the domain there, does anybody remember the word you used to describe things that are not fractions? Begins with an I. Like this is all real numbers, but integers, yes. So if you ever have a problem you have to describe, and the domain is discrete, like 1, 2, 3, nothing in between, you'd use the word integers. You'd say like all integers greater than 0. Okay? But this is all real numbers greater than 0. It's just a lot shorter to write what I circled. But those two things mean the same thing. All right, so we got that. Let's move that out of the way. And now the other thing they want to know, is it discrete or continuous? Okay, discrete, think, how can I say it? Discrete means it's only certain numbers. It skips. Okay, discrete skips. Continuous means you don't skip. You don't skip anything. Okay? Think about like if you continuously listened to a song from the beginning to the end. Continuous means you didn't skip any part of the song. You listened to the whole thing. Okay? So, is this domain discrete or continuous? What do you think? It's continuous because continuous can have decimals. Okay? It has every number, every single number. Okay? Discrete skips. So this is continuous. What if I asked you, you're buying tickets to go to a concert? Would that be discrete or continuous? That's discrete because you can't buy 1.5 tickets. You can't buy 2.3 tickets. That's discrete. You can buy 2. You can buy 3. There's nothing in between. Okay. So that's it. That's what they're looking for that one. Okay. This one. What are these bars called?
Absolute value.
Yes, absolute value bars. Okay, so we did that. That was way back in chapter 1. Absolute value bars first thing you have to do is get rid of them. Does anybody remember how many problems you have to split it into to get rid of them?
2.
Yep, you gotta split it into 2. And then you're gonna solve each problem separate. A lot of people were able to get this after I gave them the hint. Can somebody give me one of the problems?
I have a question.
Yep.
How do you know you split it into 2 problems and that it's not just like a one-step equation?
Because anytime you see these bars around it, you have to split it into 2.
Oh.
If it didn't have the bars, then you would not have to split it. But we need the first one we have to split it into.
One of them is 4y minus 6 equals 3.
Yep. So 4y minus 6 equals 3. And the other one?
4y minus 6 equals -2.
Yeah. The only difference is you keep one of them exactly the same. The other one, you make the number on the other side negative. Right. And now we solve each one, and it's going to be exactly the same steps because they're very similar. What's the first step for that equation on the left?
Plus 6 over.
Plus 6 plus 6. And it's going to be the same here. Plus 6 plus 6. That's gone. That's gone. 3 plus 6 gives me how much? 9. How about negative 3 plus 6? 3. And what's going to be my last step? Same on both. Yep. Divide by 4. Divide by 4. Divide by 4. Divide by 4. 4 divided by 4 is gone. There's your answer. 9/4. 4 divided by 4 is gone. There's your answer. 3/4. The only problem is they want me to graph it. Well, I can't really graph fraction. I need to change the fraction to a what?
Decimal.
Change it to a decimal. Yep. So on my calculator, just do 9 divided by 4. 2.25. Right? 3. Does anybody know what this one is? What? 0.75. 3/4. That's like 3/4. Right? 0.75. Okay. Now, when you're graphing, you're not putting an arrow. Okay? The only time you put an arrow is if you had something like a greater than or equal to, less than, something like that. When you have an equal to, and they ask you to graph it, it's just a dot. Or in this case, 2 dots. One at 2.25. Right? Just kind of estimate it. That's fine. And then one at 0.75. So maybe like right about there. It doesn't have to be exact because it's a decimal. I'm just kind of looking at you got it in the right spot. Okay. Any questions on that one? All right, so that's solving an absolute value equation. All right, let's look at this one. So this one says solve, but it didn't say graph. This is the kind of problem, if it said graph, you would be putting like open circle, closed circle, and then shading with an arrow. Okay? But they didn't have you graph it. So we just solve each one separately. Right, how about Maya? What's my first step for that one?
Well, you have to plus the 8, so.
Plus 8 on both sides. And if I plus 8, negative 8 plus 8 is gone. How about Leilani? What's on the left-hand side now?
I mean, negative 2x.
Negative 2x, yep. And Kelsey, what would be on the right? Yep, negative 2. All right. Now, what would my next step be? Do what? Yeah. Yeah, what's my next step? We got to be careful with this step. Because something's going to happen here, yep.
Then you divide negative 2.
Divide by what?
By negative 2.
Divide each side by negative 2. Now, I should be thinking something right now. What's going to happen here? You just divided both sides by a negative. Yep. You have to flip the sign. Right? Anytime you multiply or divide by a negative, that sign needs to flip. Okay? This is gone, just like usual. Negative divided by negative is a positive. So now we have x is greater than, what's 2 divided by 2?
-1.
1. So x has to be bigger than 1, or now there's something else it could be. So now we have to solve this one. So it's almost like an absolute value problem in that you've got two things you have to figure out. So now let's figure this one out. Yep.
Oh, what? Is or one? They point like towards each other.
Usually, or they end up pointing in opposite
Yeah,
directions.
that's what I thought.
This is what an or problem usually looks like when you graph it. Something kind of like that. And is when you end up shading between. Okay, so if this is an and problem, usually you shade between. But an or problem usually points opposite. Yep. We only did an or problem on the worksheet, but that doesn't mean the midterm might not have an and. It might have an and or it could have an or. Okay, but it'll probably be one or the other.
What's the difference between or and?
How you shade.
Oh.
So this one, it's going to be the same steps again. +8, +8. Tristan, what's 6 plus 8 give me? Tristan, yeah. What's 6 plus 8 give me? 14. And on the left-hand side, I still have negative 2x. Gianna, what's my last step here? Yep. And she just divided by a negative, so I can cancel this stuff. What else should I remember to do? Flip. 8's to be pointing that way. So x is less than or equal to, what's 14 divided by negative 2? Negative 7. So if I said to you, I want you to pick a number in your head that fits this condition, you could either pick a number that's bigger than 1. So you can think of anything you want that's bigger than 1. So that would be numbers like on a number line going this way. Or you could pick a number that's less than or equal to negative 7. Notice on that one, I shaded it in because it had the equal to under it. Now, they did not have you graph it. You didn't have to do that graph. But you might have to do a graph like that on the midterm. All right? So open circle if it's less than or greater than. Filled in circle if it has the equal to.
Can I go to the bathroom?
Yeah. Great. Any question on that one?
I have a question.
Yeah.
So for or you shade away, and then for and you shade like inside between the two, right?
Yes. Yep, usually an and is between the two circles. Like if I said to you, pick a number that's greater than 1 and less than 10. That means you could pick anything between 1 and 10. Bigger than 1, but smaller than 10. It's between. Okay? That's an and. Okay, let's look at 5. Solve the equation for y. Okay. Basically what you're doing here is rewriting it in y equals mx plus b. We hadn't studied that yet in section 1.5. Okay, so I didn't teach it to you that way. But that's what you're doing. To get y by itself, move the things that are furthest away from the y first. Okay. What term is furthest away from the y right there?
6x.
6x. Positive or negative?
Positive.
That's a positive. So to move it, you do the opposite operation. You're going to do a negative 6x and a negative 6x. That's gone. Okay. What's on the left side now?
Y.
A little bit more. More than just y.
Negative 4y.
Yep. Negative 4y. And on the right, you can't combine that. All you can do is this. Negative 6x plus 12. Okay, is y by itself now?
No.
No, what would be our last step?
Divide by -4.
Divide by negative 4, negative 4, negative 4. When you do division, you have to do it in all 3 spots. this and this are gone. Now what's on the left? What's on the left now? Y. That's exactly what we wanted. It said to get y by itself. Okay? When you have more than one variable in a problem, and it says to get one of them by itself, you're not going to get a number answer. It's not going to be like y equals 2. That's not what they're looking for. If you've got multiple variables in a problem, all you're doing is moving stuff around. Okay? That's all you're doing. -6 divided by -4. What's a negative over a negative? Positive. So we can cross that out, cross that out. 6 over 4, does that fraction reduce? 3 over 2. 3 over 2. And what letter do we want to keep next to it? Keep the x. Now, +12 divided by -4.
-3.
So all we have to do is put -3. You're not wrong if you put plus -3, but all you have to do is write -3. It's the same. Yeah.
What do the Oh wait. I'm confused what happened after the. Like I got like. Oh, never mind. No, I accidentally had 2 over 3.
You're okay?
Yeah.
Okay. So that's it. That's your answer. That's all you got to do. Now, in a problem from chapter 3, we would have probably taken this one more step and said, now graph it.
Oh no.
Here's your rise. Here's your run. And what do you call the number at the end? That's your y what? Intercept. Okay. In chapter 1, we hadn't done any of that stuff yet. So you don't, that's all you had to do. Okay, you don't have to do anything else. Okay, number 6. Does the table represent a linear or nonlinear function?
Linear.
Okay, so the key, if it's linear, means there's a pattern. And the pattern is you add or subtract the same number over and over. So, what do you add to get from -2 to 0? 2. Let's check. What do you add to get from 0 to 2? 2. What do you get when you go from 2 to 4? +2. Okay, so what that means is right now we have a pattern in the x's. You also have to check the y's. How do you get from -1 to -3?
2.
-2. -3 to -5?
-2.
-2. Next one?
-2.
Perfect. So that means it's linear. Okay, that's how you tell if it's linear. Now, if you had a picture, how do you tell if something's linear? It's a perfectly straight line. This is non-linear because it curves. Linear is a straight line. Okay? If you've got a picture, it's easier. If you've got a table, you have to check that pattern.
Wait, so it could still have a pattern and be nonlinear?
Yes, like say 2, 4, 8, 16. That's a pattern where I doubled each time. That's not adding or subtracting. All right, so the absolute value problem. Okay, I'm going to show you guys how to do this one because it takes a little bit. But step 1 is to set what's inside the bars equal to 0. Set what's inside the bars equal to 0. If it's just an x, that's the easiest case you can have. Right? If it was like x plus 3 inside the bars, then you would have an x plus 3 right there. And you'd have a little more work to do to get x by itself. So step 1, set what is inside the bars equal to 0. Now, solve for x. There's nothing to solve for here because x is already by itself. This is what we call our middle value. If you remember, we made a table with 5 values. So we're going to put down 5 values. That's going to be the middle one. Okay? So you set what's inside the bars equal to 0. Solve it. That number is your middle value. Then pick two numbers that are smaller. -1, -2. Pick two numbers that are bigger. 1, 2. And now fill them in and see what you get. Okay. What's the absolute value of -2? 2 plus 2. 4. What's the absolute value of -1?
1.
Plus 2.
3.
3. What's the absolute value of 0? Plus 2. 2. Now watch what's going to happen here. What's the absolute value of 1? 1 plus 2? 3. And what's the absolute value of 2? 2 plus 2? 4. If you followed my directions and you found the middle one correctly, these two numbers are going to repeat themselves. So you get the 3 and then the 3 repeated, and the 4 and the 4 repeated. And when you graph it, it's going to look like a V shape. So -2, 4, -1, 3, 0, 2, 1, 3, 2, 4. That's what your graph looks like. Now, the normal V shape is here. I'm just putting it there for reference. How did the black one move compared to the original one? Up how many?
2.
Yes. So when it says describe, compare, or this part, compare to the graph, it's a shift up 2. There's a chart in 3.7 that describes all the shifts. I can't go through it all right now because there's a lot of them. But when you add outside the bars, it moves it up. Okay? If you had a minus outside the bars, it would go down. Okay. Now, describe the domain and the range. For absolute value, is there any number you're not allowed to take the absolute value of? Like, is there any number that you're not allowed to make positive? If you tried to? Oh, Elizabeth? What do you think? Is there any number you can't take the absolute value of? The absolute value of 0 is 0. Yep, we did that. So you can take the absolute value of 0. No. You can take the absolute value of positives, negatives, fractions, decimals. So the domain, all real numbers. That's always the domain for every absolute value. We learned that back in that section. Now, the range is how high and low the graph goes. Does this V shape go down forever?
No.
No. Does it go up forever?
Yes.
Okay, then it must have a lowest value and go up from there. What's the lowest value on that V shape?
2.
2. So the range is all numbers greater than or equal to 2. Okay, and the last one I'll do for you guys real quick. You work at a carnival for 4.5 hours, you make $33.75. What do you do with those two numbers to find out how much you made per hour? Divide. 33.75 divide by 4.5. Anybody get how much you make? Nice. 7.5. Okay, so guys, quick reminder. Tomorrow we're going to do part 4 of the review. Okay, part 4 of the review.